Good day, everyone. We are very thrilled today to discuss what is a hardware interrupt and some examples of a hardware interrupt. Hi, I am MJ Ramitor, and together with my partner again, we are going to talk through about what is a hardware interrupt. So, shall we begin? We shall. Well, first of all, what is a hardware interrupt? A hardware interrupt is a signal received by the program from any of the variety of hardware devices like a keyboard, printer, etc., letting the program know that it needs the processor's attention on more priority than the currently executing operation. The interrupt does this without waiting for the current program to finish. It is unconditional and immediate, which is why it is called an interrupt. It interrupts the current action of the processor. Hardware interrupts can be either maskable or non-maskable. Maskable interrupt is the hardware interrupts that can be delayed when a highest priority interrupt has occurred to the processor, while a non-maskable interrupt, the hardware that cannot be delayed with immediately be serviced by the processor. An example of a hardware interrupt is a scanner interrupt, and I feel like a scanner interrupt and printer interrupt is kind of the same, I guess. So a scanner can generate interrupts in certain scenarios, such as when it has completed a scanning task or when an error has occurred during the scanning process. When a scanner has completed a task or encountered an error, it can generate an interrupt signal to the computer's system's CPU to request attention. This interrupt signal is typically sent via the scanner's interface, such as USB or FireWire, and is handled by the operating system or scanner driver. The interrupt handling routine that is executed in response to the scanner interrupt can perform a variety of tasks, such as reading the scanned image data, updating the scanner status, or handling any errors that have occurred. Once the interrupt is handled, the CPU resumes its previous tasks and the scanner can continue with its next task. More about this will be discussed by Clarence.
So hello everyone, I'm Clarence Marino, and for today's discussion guys, I will discuss to you about the INTR or the INT-R. So first, let's just define the INTR and to know what is INTR. So INTR is a maskable interrupt having the lowest priority among all interrupts. It can be disabled by resetting the microprocessor, or the microprocessor checks the status of INTR signal during the execution of each instruction. And there are questions about the INTR. So here is one question. What is the use of INTR interrupt? So the INTR is a maskable interrupt because the microprocessor will be interrupted only if interrupts are enabled using set interrupt flag instruction, and it should not be enabled using clear interrupt flag instruction. The INTR interrupt is activated by an input-output port. And for us to know what is the purpose of the interrupt flag, I will give you a brief discussion or explanation about the interrupt flag. So the interrupt flag IF is a flag bit in the CPU's flags register, which determines whether or not the CPU will respond immediately to maskable hardware interrupts. If the flag is set to 1, maskable interrupts are enabled. If reset set to 0, such interrupts will be disabled until interrupts are enabled. So here is another question about INTR. So what is the significance of INTR in 8085 microprocessor? So the INTR is the only non-vectored interrupt in 8085 microprocessor. Maskable interrupts are those which can be disabled or ignored by the microprocessor. And INTR is a non-vector interrupt, So in this type of interrupt, the interrupt address is not known to the processor, so the interrupt address needs to be sent externally by the device to perform interrupts. And one of the example is the INTR. And when the INTR signals goes high, the following events can occur. So, first is the microprocessor checks the status of INTR signal during the execution of each instruction. And second is when the INTR signal is high, then the microprocessor completes its current instruction and sends active low interrupt acknowledge signal. And lastly, when instructions are received, then the microprocessor saves the address of the next instruction on stack and executes the received instruction. And in conclusion, the interrupts are important because they give the user better control over the computer. Without interrupts, a user may have to wait for a given application to have a higher priority over the CPU to be run. This ensures that the CPU will deal with the process immediately. And interrupts are response by the processor to a process or event that needs immediate attention from the software. And interrupts alert the processor and servers a request for the CPU to interrupt the currently executing program or code when permitted, in order so that the event can be processed within a good time. And that's all for our report, guys. I hope that you have learned something, and thank you for listening. Bye.